Welcome to episode 13 of Ask the Grounding Experts, where our experts from E&S Grounding Solutions answer your engineering questions about the world of grounding and earthing. Today, our engineer with a beer, well, he's not drinking now, but he has been known to enjoy an IPA every now and then, David Stockin wraps up our latest two-part series, What is Continuity Testing? Take it away, David.
All right, welcome back, everyone. So this is going to be part 2 of our continuity measurements series here. Last week we talked about the standard 2-point continuity, which is a traditional, like your multimeter with 2 wires on it. And if you recall, if you watched that video, we're trying to measure the low impedance fault current path, or the conductive path, metallic path in our grounding system back to some sort of reference point, right? And you can almost envision that as kind of like this long distance check across, we were talking about a 100-foot by 100-foot substation, and we found the master ground bar inside of the blockhouse. We had like these kind of long distance measurements from the blockhouse all the way out to the far corner and all the way back through this massive network. Well, in this case, we're going to take our continuity meter, our clamp-on ground resistance meter, and we're going to use it for continuity in this case. And if you recall, on a clamp-on ground resistance meter, it's 2 Rogowski coils. Right? One of them's active and one of them's passive, and it's going to induce a current. And what we see, instead of this long distance kind of continuity check, we're actually going to get a kind of a local area continuity check. What do we mean by that? So we're at our substation. We're in our substation. We have, say, a switch, and there's 2 ground wires tied to it. It's a big square box with stuff in it, right? And that square box outside is covered with a metal case, and it's got 2 ground wires tied to it, bonded to it, and leading down to our grid to make sure that any charges that got on that case had a path to ground, right, and balances the voltages. So if we walk up to one of those ground wires, we clamp onto it, the active coil is going to start oscillating back and forth. It's going to induce a current into that ground wire. And it's going to go both directions. In one case, it's going to go up into the piece of equipment through the chassis that it's bonded to, across that chassis, down to the second ground wire it's tied to. And it's going to go down to the below grade grid. It's going to find a path through that ground grid back to the meter and go up that ground wire back to the meter and show us the overall drop in resistance. Right. By clamping onto that wire, we are expecting, again, a very low reading. Right. That low reading, right, will tell us that we have a nice continuous loop around that equipment, a local area continuity check. Right. Now, let's say, for example, one of those ground wires was broken and had fallen off. Okay. When we did our standard traditional 2-point meter, where we came from the ground bar, we went out to that switch. If we checked that ground wire, we say it was kind of close, it was on the case, but we didn't know there was a bunch of corrosion between the case and the ground wire, so it was actually open and wasn't connected because of the corrosion. Our continuity meter would still show that, from our 2-point continuity meter, would have shown that as still being a nice low fault current impedance path. A low impedance fault current path would have still been nice and low. It would have measured that. But our clamp-on meter now would show it as a high, or show some resistance there. And it would show that it's not, in fact, bonded as well as we thought it was. So our 2-point method showed us that there's a path all the way back to our ground bar in our blockhouse, but our clamp-on meter shows us that the path around right in the local area is either good or not so good. And in the case of corrosion, it's going to show some resistance there, and we're going to be able to pick up the fact that at least one of those conductors has a problem. And we can then make sure that maintenance is issued to go out, pull the bolts, clean off the connection, re-put in new bolts or new hardware, new penetrox, and get that thing reconnected so we have a nice solid connection there. Right. The other thing that clamp-on meter will do for us is also measure amperage. So if we do have a leakage current being generated, we're going to be able to see it. We're going to see how much amps is on that thing and whether or not it's above our standard. Generally speaking, we're looking for something below 1 amp. If it's much above that, we generally report that as a potential concern. It's not always a concern. It depends on where, you can have high voltage lines nearby. It could be inducing. It could be perfectly normal. But you certainly want to know what those levels are in the amperage, and particularly if they're changing and increasing over time. Increasing amperages over time can indicate a lot of issues, including grounding electrodes that are beginning to fail. So that clamp-on meter, when we're in continuity mode, can tell us whether or not we have problems that our 2-point meter will not tell us. Now let's take another example. Let's take a lightning arrestor for one of our incoming power lines. So we have a power line coming in. Let's say we have 220 kV power line coming in, and on phase A we have a lightning arrestor that's designed to short to ground should the voltages go too high above our line voltage. It'll dump it to ground. And there's one and only one ground wire tied to that lightning arrestor and that post. When we walk up to that and we clamp on it now, our active Rogowski coil is trying to send energy in both directions. So it's going to send it down into the ground grid, but it's also going to send it up our lightning arrestor post. And because there's only one connection and there's an insulator between the wire and the post, it's going to go up and it's going to stop. And it's going to measure an open on our lightning arrestor. Our meter's going to say this has only a single connection, it's an open. Our 2-point meter, meanwhile, if we brought it over and we tied to it, it would show it as a low, a closed, right? It's going to show a low resistance. So that is actually what we're looking for. That's called an isolated ground, right? It has a single connection point to it. And by using our clamp-on meter, which shows a high resistance, and our 2-point meter at the same time showing a low resistance, we can confirm that that is in fact a properly bonded system that is an isolated ground. So when you're looking at some of your metering systems and measurement systems where you're trying to put an isolated ground, that's how you check it. You want the clamp-on meter to read high and your 2-point meter to read low, and that tells you you've got a properly isolated ground. Right? If you think it's an isolated ground and you go up with your clamp-on meter and you clamp on it and you get a low reading, it's not properly isolated. It's got another connection somewhere causing a loop, and that can allow currents to flow and damage whatever sensitive equipment you have inside of your site there. So understanding how a clamp-on meter works, we call it the Swiss Army knife of grounding. We can use it for resistance to ground measurements. We can use it for continuity measurements. We can use it for amperage readings. And we can confirm whether or not we have failures in our continuity, failures that are bonds. And we can use it for checking to see if we have properly isolated grounds. This meter is very important. It's a very powerful tool, and you need to be able to take all of this data and put it together and analyze it to see what your grounding system is like. We talked earlier, it would be wonderful if we could just call Scotty up in the Starship Enterprise and scan our system and tell us everything that's going on. We don't have that anymore. We got engineers, and we've got 4-point methods, we got 3-point methods, and 2-point methods. We need to take all of that data, put it together side by side, and analyze it using our brains and figuring out what that data is trying to tell us. And by putting that together, we can get a very comprehensive understanding of the effectiveness of our grounding system and whether or not it's going to protect people, protect equipment, clear our faults as we need it to, and whether or not it's corroding, and that's really and failing over time. And this needs to be done, all these tests need to be done regularly, not just once in a blue moon, but regularly, so we can see those changes occurring over time, right? If the resistance was 5 ohms today, but it's 10 ohms tomorrow, you probably want to know that. Right? If the amperage coming off of your transformer was 1 amp today, but all of a sudden it jumps to 50 amps tomorrow, you probably want to notify somebody that you've got a big problem with that transformer. Right? It's the changes over time that are more important in analyzing our grounding systems than any single thing. And we need to look at all of these test methods and put them all together in order to get that comprehensive picture of our site. And again, one day we'll call Scotty on the Enterprise to scan everything for us. We'll all be better off, hopefully, when that day comes. But for now, we need to use the tools that we have in hand and our brains and put it all together to get a comprehensive picture. So this concludes our continuity series and our series on testing for now. I'm sure we will come back to it at some point down the road. Please give us your feedback. There's a thumbs up button down there, I think, at the corner. Maybe it's down here. I don't know. Click that thing, mash it, subscribe, send us a note. Put a comment in there. We'd love to get your feedback. Post a question up, and you never know, we might do a video based on one of your questions in the near future. So thanks a lot. We'll talk to you guys later. Bye.
Thanks so much for watching. If you found this episode helpful, please give us a quick like down below and subscribe to stay up to date on future educational videos we will be publishing. And feel free to post questions or comments below as well. We might even feature your questions in future videos. If you want to learn more about the amazing world of electrical engineering and grounding, be sure to check out our certified online courses at the links in the description below to kickstart your career. We'll see you next time.